Transpose, subtraction, addition, matrices, could it be types of matrices? Multiplication? Hey buddy, need help? Sure, but how? Just wait and see. Where are we now? We are trapped in this book. Okay, but let's start with the definition first.
Matrices is a rectangular array of number enclosed between brackets.
Let's go to the next stop. Yes!
I'm gonna teach you about first dimension, secondly number, and last one equality. This is the general form of matrices with m rows and column. When we talk about rows, we will always refer to the horizontal rows, while when we talk about n column, we will always refer to the vertical column. The dimension of the matrices will be times n, which will be 2 times 3 for this type of matrices. The number of matrices is represented by a, small I, and small j. I is referred to the m rows and j is referred to the m columns. When we talk about number of matrices, according to this example, when the question asks you what is A21, you need to refer to the row number 2 and the column number 1, which in this example the answer is 7. The A33, you need to refer on the row number 3 and the column number 3, which will be 2. Equality of matrices is actually the very easy one, because to understand this, you only need to refer to 2 different matrices, and the both matrix is said to be equal when their dimension at its corresponding entries is exactly same.
I think I have not enough. No, but
let's move on to the types of matrices. There are zero matrix, square matrix, column matrix, row matrix, diagonal matrix, identity matrix, lower triangular matrix, and the upper triangular matrix. Firstly is the row matrices. Row matrices is 1 times n matrix. As the example below, we can see that the matrix has only one row. Secondly is the column matrix. Column matrix is m times n matrix. From the example below, we can see that the matrix has only one column. Let's move on to the next matrix, which is square matrix. Square matrix is n times n matrix, which has the same number of rows and columns. From the example, we can see that there is 2 times 2 matrix and 4 times 4 matrix. This matrix forming a square shape. This is how the matrix got its name. Next is zero matrix. Zero matrix is m times n matrix, which every entry is 0 denoted by O. As we can see, all the numbers in matrix are 0. Let's talk about the diagonal matrix. Diagonal matrix is square matrix, which non-diagonal entries are all 0. Let's take a look at the numbers that I have highlighted. They are filled with valued numbers, but the non-diagonal part are filled with zeros. Next is identity matrix. Identity matrix is a diagonal matrix where all its diagonal entries are 1 and denoted by I. As we can see here, the non-diagonal part are filled with zeros. Now let's talk about the lower triangular matrix. Lower triangular matrix is a square matrix and ij equals to 0 for I less than j. This matrix has 0 entries on the downwards diagonal and non-zero entries below it. Lastly is the upper triangular matrix. Upper triangular matrix is a square matrix and aij equals to 0. This matrix has all the elements below the main diagonal as 0.
Great job! You have aced this part.
phew, that's a long journey. Are we done? We got some more to be learned.
Best of luck, kiddos.
Oh my!
There are also operations in matrix.
Look at that!
Both matrix are of order 2 times 2, so we can perform addition of matrix. We can just simply add corresponding matrix together. For an example, in matrix A, 4 is located at first row and first column, A11. So we can add 4 with element at the same row and column in matrix P, P11, which is 1. Same goes for the rest of the elements in both matrices. It's just the same for subtraction. Both matrices are of order 2 times 2, so we can also perform subtraction of matrix. We can just simply subtract corresponding matrix element together. For an example, 8 is located at first row and second column, A12. To perform subtraction of matrix, A must subtract elements that has same row and column in matrix P, P12, which is 0. So, the answer will be 3, 8, -2, and 5. Scalar multiplication is a bit different.
What's the difference?
If order of matrix A is m times n, order of matrix B is n times p, so AB has order m times p. Just multiply each element of column of first matrix with each element of rows of second matrix and add them all. Based on the explanation that I've told you before, 4 in matrix A is multiplied by 1 in matrix B, and then 8 in matrix A is multiplied by 5 in matrix B, and then you sum up two of the products to be the elements in the first row and first column. Matrix AB is 44, 16, 38, and 14.
So easy.
Remember, to perform addition and subtraction of matrix, the orders of both matrix must be the same. To perform scalar multiplication, rows and columns of different matrix must be equal.
I know everything about matrix now. Wow!
You don't even know me yet.
Who are you? It's transpose matrix.
Transpose matrix of matrix A, written as A, is matrix obtained by interchanging rows and columns of A. For an example, in matrix A, 1, 0 is the first row of matrix A. So, in transpose matrix, 1 and 0 becomes the first column.
Wow, matrices is just a piece of cake. Yeah, I agree. It's easy as ABC. Okay, let's go home. But how can we get out from this book? To get out from this book, both of you need to answer a few questions. Well done, you have mastered this topic.